What is TorchVision Transforms? TorchVision Transforms are used to prepare images before feeding them into a neural network. So, why? These models don't understand raw images. They need consistent size, normalized values, and tensor format. So, here are the five key transforms we need to know. First is tensor or two tensor. Most important first step. What it does is that it converts image into IPyTorch tensor. Changes pixel range from 0 to 255 to 0 to 1. It changes the shape from height width channel to channel height width. Example, we import the transforms from the third vision and transform the two tensor to the transforms. So why it matters? Neural um, networks expect tensors that images scaling from 0 to 1 makes training more stable. Think of it like convert plus normalized scale. Next is to PIL image. This is the reverse of the to tensor. What it does is convert tensor to image PIL format or pillow format. When to use? It's used in visualization, debugging, and saving images. Um, Third tensor, think of it as tensor, the image for humans. Next is resize. Make all images the same size. Um, what it does, resize the image to a fixed size, like um, using the codes transform that resize to set the parameters of 224 to 224. Why it matters, neural network require fixed input size. And the important behavior, if not square, um, smaller edge, it resize first. And aspect ratio is preserved. So think of it like standardized input size. Next is center crop. Focus on the center of the image. What it does is crop the center region and transfer that center crop like for 20 to 24, which means um, um, we're going to crop some of the sample images to the center. What matters is removes irrelevant edges or noise. Keeps important object usually in the center. Think of it like keep the important middle part. Next is normalize. Very important for training performance. What it does is applies normalization per channel. Like if you want to normalize some of the features, you need to subtract the feature into the mean divided by the standard deviation. It makes the mean into the center. If we calculate all the features again, taking its mean, the mean will become 0 and the standard deviation is 1. Why this is so powerful? From your file, normalization centers pixels values that improves gradient flow. The benefits of it is for faster training, stable gradients, better convergence. Think of it like balanced data so the model learns faster. So let's putting all together in a pipeline. We need to transform the compose. It um, um, it's like a stack here and transform the precise. Next is transform the center crop, transform the two tensor, transform the normalize, go to the mean and standard deviation. So here's the key insights. Why we normalize? The answer is to center the data distribution and establish gradients updates, leading to faster and more stable training. Why the tensor first? Because PyTorch model operate on tensors, not in images. Why fixed size? Um, because neural networks require consistent input dimension for batch processing. So, in summary, the tensor is to convert the image from tensor to 0 to 1 scale, resize to fixed size, center crop is to focus on the region, normalize stabilized training, and to PIL image is to convert the tensor to the image format.